Hi everyone, I've been working in software development for 8 years now, and in this video I want to share one thought that I came to over time. Your job alone will not necessarily make you a better engineer. When I first started working professionally, I truly believed that if I just did my job well, kept reading books, learning new technologies and applying them in practice, then over time my level would automatically grow. It felt logical to me, and I thought that if I worked long enough, progress was simply a matter of time. But over time, I started noticing something different. On any real project, there are always deadlines. Requirements change, business priorities shift, and the code base evolves depending on how many people are working on it. And there is constant communication needed to make sure everyone understands the tasks the same way. There is always legacy code. There is always tech debt that everyone sees, but its priority is usually lower than the current sprint goal. And very often you're not solving deep engineering problems. You're solving business problems within strict constraints. Also, the tech stack on a project almost never changes from the beginning. Yes, there are some exceptions, but usually that only happens when a system is rewritten fully from scratch. Most of the time you work within the same boundaries for years, and there is nothing wrong with that. And at some point I realized that simply having a job is not enough for me. A job gives you experience, it teaches you responsibility, it makes you reliable, but it doesn't always push you into situations where you are forced to think much deeper. Often it teaches you stability more than complexity. And this is not criticism, this is just reality. So I decided to consciously create a different kind of environment for myself, one where I'm not limited by deadlines, not restricted by architectural decisions made years ago by someone else. And I set a goal to build my own product, not just a small pet project, but a technically complex system with serious architectural requirements. So I started building an iOS app for personal finance and defined strict principles from the beginning. All money operations must follow double-entry bookkeeping principles. The app must work fully offline. The same user must be able to use it on multiple devices, and the system must correctly handle multiple currencies. And very quickly I realized that this was much deeper than I expected. For example, double-entry bookkeeping is not just about debit and credit, it's about system invariance. It means that every transaction must always be balanced and the system must never be able to store an inconsistent state. So I started thinking, how can I guarantee that no operation will ever violate these rules? I explored different validation approaches and eventually moved part of the logic to the database level. I started using triggers that verify that total debits equal total credits before the transaction is stored to the database. If the balance doesn't match, the database simply rejects the write. Even if there is a bug at the application level, the system as a whole remains consistent. And for me, that was a major shift in thinking. I wasn't just implementing features anymore, I was designing guarantees. But that was only the beginning. The next challenge was offline mode and synchronization between devices. How do you make sure the app works perfectly offline and the later synchronizes without breaking consistency? How do you prevent conflicts when the same user performs operation on different devices? How do you combine local speed with global correctness? And that is when I started diving deeply into topics like event sourcing, CRDTs, logical clocks, distributed snapshots, and so on. And not just reading about them out of curiosity, but actually using them as part of my architecture. And there were many moments when I didn't understand what was happening. I was drawing diagrams to break problems down step by step. I reread articles multiple times. I went back to book chapters that I thought I had understood, only to realize I hadn't. And sometimes everything felt overwhelming. And honestly, there were periods when I felt like I was in the middle of the ocean, not fully sure if I even moving in the right direction, if I even moving at all. And what is interesting is that I intentionally avoided immediately asking AI for the correct answer. And not because it's wrong to use it, but because I wanted to go through the process myself. I wanted to struggle a bit, or maybe not a bit, to look at the same problem from another angle and to try one approach, see why it doesn't work, and then try another one. And I clearly remember one moment when I was just walking outside thinking about some synchronization problem, and I suddenly realized something very simple. I am not learning theory just to learn theory. I have real problems to solve, and theory becomes understandable because I am inside the context of those problems. And that changed something for me. From that point on, I started seeing learning process differently. Every time I hit a wall, instead of thinking maybe I'm not good enough, I started thinking there is something here that I don't know yet. Even now, when I face something complex, I sometimes think maybe I won't be able to solve it. Maybe it is too difficult for me, and maybe I need a completely different approach. But over time, things start making more sense for me, and every solved problem builds a different kind of confidence. When I look back, I can see how much this project changed for me. The tasks at my main job didn't suddenly become dramatically harder, but I became much more confident in my decisions. I stopped feeling like my knowledge was on the edge, because I had already worked through problems that were significantly more complex in my own project. So, if I summarize everything in one sentence, your job alone will not necessarily make you a better engineer. It can make you experienced, it can make you efficient, and it can make you reliable. But I believe real depth often comes when you intentionally put yourself into difficult technical situations and take responsibility for architecture, consistency, and system guarantees. And I think if you truly want to grow as an engineer, set goals that challenge you. Create problems that feel slightly beyond your current level, and that is where growth actually happens, at least for me. Thank you guys for watching this video. If it was helpful or interesting for you, feel free to subscribe, and see you in the next one.